All right. Good morning, everyone. Welcome back to Comp 3350 Software Engineering. Today is our last content class. Hooray! Hey, yeah, good. We're going to have a test on Tuesday's class, and the material for what you should consider to be on the test is up to and including today's stuff. So everything after the first test, everything after than what was covered on the first test. So there's at least 1 or 2 lectures before the first test that are covered on this one, just because we didn't get a chance to cover them on the first test. So then everything after the term break is going to be on the test. I am planning to do assigned seating for this test. Not because I don't trust you, but because if I mess it up, it's easier for me to bail out in this class than it is for the 200 people in Comp 2150. So when I'm talking about assigned seating, what I'm going to do is I will be printing the tests with your names written on them already. So your names will be on the tests. And I'm going to send you an email to say what paper number you're writing. You should expect to get that email before class, like well before class on Tuesday. And I'm going to be numbering the rows. Like I'll put up an image on the course webpage with like a layout of the room where paper number 1 is and where paper number 76 is, the last paper in the class. So you have a sense of where your paper is going to be before you get here. But you'll need to you'll have to sit at the paper that has your name on it because it has your name on it already. If there are other accommodations that need to be made for testing, it will be handled. It's nothing to worry about. I'll make sure that the right test gets to the right place. But you should expect an email from me before class on Tuesday. If you don't get that email from me before class on Tuesday, if you don't get it from me by the end of the day on Monday, send me an email and I'll let you know. I'll just reply to you. But I will also just have the seat assignments on my machine in front of me in class. So if something really goes wrong, we can just work it out. But yeah, you're going to be my guinea pigs here. You're going to help me with this a little bit because I don't want to mess that up when it comes to 200 people in a Comp 2150 test. And I'm more than willing to mess it up a little bit here, especially because we have a bunch of extra time with the class. We're doing a 50-minute test in a 75-minute period, so there's a little bit of extra buffer time there if something goes catastrophically wrong. Today, what I want to do is finish up the legacy software stuff. I want to look a little bit at one last testing thing, and the last testing thing that I want to look at is code that is hard or impossible to test in the way that it is written in the form of relying on non-deterministic behavior. So something that changes every time you run the code. How do you test that stuff? And then time permitting, I want to take a look at some websites, evaluating presentations. So one of the last things you're going to be doing as part of your iteration is presenting your work in the form of a website, and I just want to take the time to look at some websites for products and see how those satisfy the kinds of things that we're looking for your presentation and for your website. All right, so last class we started this idea of talking about legacy software. And the motivation for this is basically when you're out in the real world, you don't usually start a project from scratch in the same way that you have in this course. You're starting from some existing code base that lots of people have previously worked on. The first activity I have for you builds on what we did last time, but as I said last time, I'm just going to skip this one. I'm going to skip this. If you feel motivated, you are more than welcome to build calc.exe on your own machine, but I don't really want to waste our time having everyone install and set up Visual Studio and then waiting for Visual Studio to compile this project, especially if you're running a Mac, because it's not even going to work. So let's just skip this part. Feel free to build this on your own time if you are motivated to do so. Congratulations! Let's pretend that you built the software and you've got calc.exe sitting on your machine right now and you're able to run it. Maybe. The purpose of all of this is that we want to first find all that information about the project. So what is this project? Who's it for? Who are the people that are involved in it? Who can I ask questions if I need to ask questions? Get the software on our machine, build it so that we have a working product or project on our machine. Now we want to actually go through the process of doing what we were asked to do in the first place. So fixing the bug that has been provided to us. This is your job, fix this bug in this code, or add a new feature to this code base. The questions that we want to ask, or the questions that we want to answer now are, where do we actually go about finding a place to add code? We've got a new feature. We need to add code to do this new thing. Where do we find the bug? How do we find the bug to fix the problem with the code? The other half of this is that part of the code already tested? Is there a test suite that covers the code that you have decided we're going to put our code here, I'm going to fix the bug that is here? Is the rest of that code actually tested or not? When you're trying to decide where you want to add code for the project, your overall goal for adding code and fixing bugs and doing stuff with legacy software should be change as little as possible. The code that's there, in theory, works for the most part. People know how it works. They're expecting it to work in a certain way. Change as little of that as possible, but add as much code as you want. So you've got a class. Your goal here is to leave this class as much as possible the same that it is right now and add more code, either by adding more methods or adding new classes that are called from the code that you're working on. Where you actually put that kind of depends on the context, and it kind of depends on whether or not this system is architected in an architecture that you're familiar with. So if you're adding a button, if this is a UI change, if you're adding a button or changing a label on something, the right place to add that code or change that code is in the UI classes themselves. If you are making changes to the way that data is persisted to a database, or you're making a new persistence layer for your implementation, you're migrating away from HSQLDB and using SQLite, make those changes and add that code into the persistence classes in the persistence layer. If the project doesn't have a clear architecture, there's just code for all parts of what we would consider to be this three-tier architecture in all different classes. We've got presentation and logic and persistence all in the same place. Try to find code that's related to the issue that you're working with right now. So if you're making a change that's modifying some part of your data model, then make the changes as close as possible to that part of the data model, even if it does span across different architectural layers of the end-tier architecture. Here's what I'd like you to do with your team. You have a link to Microsoft Calculator. It's up on the course webpage again, or you can find it by searching for Microsoft Calculator source code. What I'd like you to decide with your team is come up with a feature that you'd like to add to this product, or find an issue. So find a bug in the code, and then attempt to find a place where you would add code and where you would add a seam. So where would you actually make a small change to this thing so that you can add the code that you're thinking of adding? I'm going to give you about 5 minutes to do this. So taking a look at what calc.exe does, if you've got a Windows machine, just like launch calc.exe and look at it to see what the built product looks like. If you are not running a Windows machine, I don't know, it's a calculator. You can get a good sense of what it does because it's a calculator. Define a new feature, choose an issue in the GitHub tracker, attempt to find a place where you would add the feature or fix the bug that you have identified. We're going to give you 5 minutes, and then we'll come back together after that. Please go ahead. Okay. So I'm not looking for any feedback here. I really just want to give you an opportunity to take a look at some code that's not your own. That's not anything that you've written, that you have an opportunity to see, like, where could you put this code? So let's say, hooray, you found a good spot that's going to work for the code that you want to add. Maybe. If you found a spot, so you've got, this is the class where the bug exists, this is the layer that I need to make a change to, great. Let's actually start making a scene between existing code and your new code. This word scene, we've seen this before. We have seen this word scene before in the context of the place between the layers of our architecture. When we're doing integration testing, we're evaluating the scenes, we're testing the scenes, we're evaluating the behavior between the logic layer and the persistence layer, on implementation of the persistence layer. Our goal with this is to take the code that exists and try to add a spot where we can kind of insert our own interface. We can insert this separation between the existing code base and the new code that we want to add, and have a place where we've got this existing code and we can call the new code that we want to add for this thing. In short, where are we going to put existing code? Where are we going to put our call to the code that we're writing in the existing code? Our job is to make that scene and then evaluate the behavior of that scene. So, our question now is the code that we've got tested? I mean, maybe, but maybe not. If this is code that hasn't been thoroughly tested, we'll say probably not. Our goal is now to make a scene that we can do an evaluation on. We want to set this up so that we can basically build an integration test between the existing code and the new code that we're going to be adding for this thing. So we want to break up that existing code into testable units. We want to change as little as possible. So when we're doing this, our goal is to try and find a small thing that we can break up into pieces that we can use for these testable units. We want to insert a seam into that code where our code's going to go. At the beginning, a good idea would be to use a test double. So we've got our existing code. We're defining an interface between the existing code and the code that we're going to write. We're defining an interface, and so we'll provide a test double for that interface. And that test double, a good choice here would be to use a fake. You could use a mock, I guess, if you want, but a fake makes the most sense. Write unit tests for the code as it exists now. So it may start calling a fake, but it should still behave the same way that it did in the first place. Write unit tests for the existing code. The existing behavior, if it's not a bug, is the correct behavior. So the way that the code works right now, that's the truth. That's the ground truth. Somebody that uses this code right now is expecting this code to continue to work, in this, provided it's not a bug. They're expecting everything that's there to work the same way that it does before, even after you've added this new feature. The existing behavior is the correct behavior. So as you're writing unit tests for this existing code, the existing behavior is what you're trying to evaluate. This is what I'm expecting these pieces of code to do. Once you have a well-tested piece of existing code that has the seam that calls your fake, now you can start making changes and adding the code that you want to add this new feature. So you can go back to the last activity, or if you found a seam, a place where you want to put this, I want you to start thinking about how you break up that target code. How would you actually take this unit of C++ code that is Microsoft Calculator, and what would you change? How would you add something? How would you add an interface for your new feature? Start thinking about what your interface might be if you're adding a new feature. So what methods would you need to call to be able to add the new feature that you've got? I'm going to give you again about 5 minutes to do this, and then we'll get back together. Please go ahead. Thank you. All right. So again, I'm not looking for feedback here. I'm just looking for this to give you an opportunity to talk about some code that's not your own and how you might start to approach making changes to it. I want to reiterate the goals here. The goal here being we can add as much as we want and change as little as possible. Whatever your feature is, whatever your bug fix is, add a new method. Don't change an existing method unless it's a bug. And if it's a specific bug that I'm going to stop talking about bugs. You're adding a new feature. If you're adding a new feature, you don't want to change an existing method. Just add a new method to do the thing that you're doing. If you want to add something to the UI, add something to the UI and have a completely different code path that's being called with your new feature implementation that doesn't touch the existing stuff. Add as much as you want, as many new classes as you want, as many new interfaces as you want, change as little as possible. Try not to add conditional statements to existing code to change the behavior of what's going on. Just add a new class, add a new button, try to change as little as possible. All right. That's it for legacy code. I'd like to switch now back to testing just for a little bit. One of the things that you may find yourself in a state of is having non-deterministic code. Non-deterministic code is code that's basically like you're using in Java math.random, or you're using the random class and you're trying to get random behavior because you're doing something like, I don't know, like a quiz show or something. So you've got something in a place where you really want to have randomness so that your user doesn't expect the output that you're producing. Another place of non-determinism, so code that changes every single time you run it, is when you're using time, actual time in your code. So if you're using like new date and you're using the current time, whatever that returns, or local date.now, or any of the APIs in Java for getting the current date, and behavior of a method changes based on what the current date is, code can be really hard to test, especially when you're starting to think about things like integration testing. So if you're doing integration testing and you're trying to evaluate, I've got records, so let's say I'm doing some kind of airline booking system. I have records that I've encoded in my default script file for this test, but my code uses .now, and I want to test things that are in the future. The only way that that's going to work is if I constantly change my script to have dates in the future every single time I run my test, which is not exactly a scalable solution to the problem. We're actually going to take a look at a specific file in a specific project that has been built up for this course as an example of the use of non-determinism in code. So we're going to be looking at Quizlate. Quizlate is a quizzing tool. It's a quizzing tool. What I would like you to do with your team very quickly is open Quizlate in your web browser. This is a link you can find. You can click this. I've also put a link up on the course webpage. Alternatively, you can clone this project into your own Android Studio because we're going to start taking a look at it for the purpose of making changes to it. I want to refactor this code so that we can make it a little bit more testable than it is right now. So take 2 minutes, get yourself set up, and then we'll take a look at the actual code that I want to take a look at. Okay, so I'm assuming that a lot of you have got this in a browser somewhere. So what I'm going to do, you'll still have a couple minutes to open this if you haven't quite got it open yet. There's a specific file that I want you to open. The path for it is source main Java, and I typed it wrong, I'm sorry. This is com quizlate logic /quiz.java. The link that I put on the course webpage, I think is direct. I forget what I did. I'm really sorry. The link, I think, is directly to this file. Is it? Yes. Okay, great. So the link on the course webpage, if you go to today's lecture section, is directly to this file. I'm going to just put it up on the screen. I've got a copy of this on my own machine. I'm going to put it up on the screen so that you can all see it. The question that I want you to start looking at is, how would you approach testing this, and why can't you test it? Why can't you write tests to evaluate the behavior in this code? I'm going to point at a really specific spot here. The really specific spots that I'm looking at are the places that have math.random in them. So take a look at those parts. There's a couple places where math.random is used here. This is in the constructor for it. I'm going to go down here to next question. This is part of the public interface for this class, so it should be part of a unit test. It uses math.random. The questions that I want you to answer here are, how would you test this? How would you approach testing this, and why can't you test it? So I'm going to give you like 3 minutes to talk about that with your team, and then we're going to come back and talk about it together, okay? Okay. So this next question method, because it's part of our public interface for this class, it really should be tested. We should have a test for this. I'm going to try to describe the behavior. Please correct me if I'm making a mistake here. But the way that this should work is basically, if the quiz itself hasn't been completed yet, so a quiz consists of a deck of cards, and if the quiz hasn't been completed, so there are questions that I haven't answered yet, it should just find one that hasn't been answered, and it's going to find them in a random order. It's going to find them in a random order. So it's not predictable. It's a proper flashcard-based quiz. I'm going to get different questions each time I do this in a different order, but I don't want to re-answer questions that I've already answered. Yeah, okay, good. So in the state that this is in right now, for me, what's hard to evaluate about this is that I'm just going to get different things every time. Different order of outputs every single time I run this. So for me to write a test that's going to evaluate that behavior, it's impossible. I can't write a test to evaluate that every question will have been covered. I can't write a test that I'm going to get this next question each time. So in the state that this is in right now, it's really hard to do that. Here are some strategies that I want to start applying to a case like this. We've got this non-deterministic behavior in our code, and that's desirable. We want that when we're actually running the code. We want our code to do this so that when you're sitting there tapping on your screen, you do get different outputs every time. But when we're trying to test our code, we don't want that anymore. So what can we do to change that? One thing that we need to start with is identifying sources of non-determinism. So this is general. Identifying sources of non-determinism here is go through your code base and find places where you're using random numbers or where you're using the current date and time to accomplish something. Once you've found those sources of non-determinism, change the code so that these sources of non-determinism are dependencies of the class. So I'm going to go back to this code here. Right now, we've got a static method call. We're making a static method call to something on the math class. When I say change this so that it is an explicit dependency of the class, there are 2 things that we could do. In this case, we could say, I know that I am using math.random internally. I know that I'm using math.random internally, and I can accept a seed for this so that I always get the same sequence of numbers generated by the random number generator. That requires us to know about implementation details of this class. So it kind of says we can't do black box testing for this. We can't do black box testing for this because that tells us that we have to know that it uses math.random internally. Making this an explicit dependency of the class, I'm going to start making a change to this class. And what I'm going to say here is that I would start to say something like private random source random, something like that. And random source would be an interface that has a method on it where I can get a random number from it. But it would be something that is something that is something that is something. It would be passed into the constructor here. So I would do random source random, this dot random, and then any place I refer to math.random, I don't know what you call it. Maybe you would just use the same, cannot spell it. What is going on? Maybe you would use the same method name, but you would be taking this as an input. So changing your code so that this is an explicit dependency. You would use the same default implementation. The same default implementation that I'm going to want you to think about, and I'm going to give you time to think about this. I'm going to stop making changes to this class right now. I'm going to get you to start thinking about this yourselves. The same defaults that I would suggest that you think about is the way that we approached staging the implementation of persistence layer in this class. Allow the dependencies to be injected, so allow them to be injected in the constructor, and then test the code with injected deterministic dependencies. The other question I'm going to leave you with here for now is, what are those deterministic dependencies? What are they? What would they be? And specifically thinking about test doubles. What kind of test double would that be, and what implementation would you expect that to have? So I'm going to give you a chance now to refactor either this code, which I suspect is group 1's job. Group 1 can do this. But what I would rather you do is find sources of non-determinism in your own code. If you can't, so take the time to try and find it, but if you cannot find any sources of non-determinism in your code, then try to start making changes to this class. Continue doing what I'm doing here. Add an interface. Describe what the test double would look like for this. Describe how you would implement a same default for this thing. Again, thinking about the way that we staged persistence implementation. And then think about how you actually start to evaluate the behavior. So what tests would you start to write for that? So I've got this. I'm going to put this slide back up right now. So the strategies. This is what I want you to start doing with your own code. Look for sources of non-determinism in your projects, and then try to start changing it so that it is not non-deterministic. So it's deterministic so that you can evaluate the behavior properly with a test. So I'm going to give you like 10 minutes to do this now. I'm going to give you 10 minutes to take the time to find this stuff in your projects, and I'd like to try and visit each of you to spend a little bit of time to make sure that we're doing okay. So please go ahead. All right. So I want to take this just a little bit further. So I want to take us to the point of me like pseudo-coding a test here. I don't want to actually write a JUnit test, but I want to get to the point of showing like what you'd inject in the front end, your presentation layer, versus what you do with the test implementation for something like this. So we've already started. We've got a random source dependency. We've called this dependency in the constructor, and we're taking an instance of this class in the constructor itself. So I'm going to create a new file here, and I'm just going to say this is something like public class flash quiz activity. And then there's all that Android stuff in it. There's all that Android stuff in it. Android stuff here. And then we've got something like public void, and I can't remember the exact name of the method, but something like onCreate. So this is when the activity is starting on the page. In this case, we would do something like we've got a flash quiz that we've got in here, and when we create an instance of this, we would say something like quiz is equal to new flash quiz. And what we're passing in here was, I think it was a deck. Let me put this to the side so we can see them both at the same time. So we've got a deck. I'm just going to say new deck. We'll say that this has been constructed in some way, so there's actually cards in it. The other thing that we're going to put in here is an instance of a random source, actual random source. So I'm going to call this actual random source. And in class actual random source, we'll have private, public. I don't know what math.random returns. Is it double or float or something? Float. Public float random. And what this is going to return is math.random. So we're going to inject this actual implementation of this in our presentation layer. In the Android implementation, when we create an instance of this flash quiz, we will inject that specific one. And that specific one is going to just do random stuff, which is kind of what we want from a user's perspective. In the code that's testing, so I'm going to say now public class flash quiz test. And the test that I want to write is at test public void test next card. I think that's what it was. In this case, the way that I'm going to do this is I'm going to say random source R is equal to mock random source dot class. You could make a fake or you could make a stub implementation of it if you want, but I'm just going to use the mocking library to do this for me. And what I'm going to say is when r.random then return what's a good random number? 2. Thank you. That's an excellent random number. And then I'm going to say flash quiz Q is equal to new flash quiz, new deck. I will mock a deck, or I will use an actual instance of a deck. But here I'm going to put in this mocked out random source. My behavior now, when I call quiz.next card or next question, my behavior is deterministic. I know that it's always going to return this when I call it because my randomness is gone. I've taken all the randomness and I've replaced it with always return this value. Our goal with this is to basically say, find that non-determinism, make the non-determinism a dependency so that we can inject determinism when we're trying to evaluate the behavior. If you're testing something that has dates in it, so you're using either local date.now or you're using new date, so these are both approaches to get the current time that will give you different values every single time you call them. The general approach here is the same. Your random date or date source interface would be like get current time, and your one implementation, actual date source, would return new date, or it would return local date.now. The mocked version of it would return a specific date. It would always return March 23rd, 2023. And that's going to happen because you told it to always return that specific date, as opposed to just whatever the day happens to be right now. So taking that non-determinism, pulling it out into a dependency makes it so that we can evaluate the behavior of these implementations. All right. Can you do that? You got it? Good. Okay, so team 1 is good to go. Are there any questions? Are there any other places that you have observed any non-deterministic behavior? I could pick on team 5 right now. They have a. What's that?
Do you want us to talk about it?
Well, I legitimately want to, but I'm also feeling terrible about doing it because I'm constantly picking on team 5. Okay.
Yeah, so we use like location tracking. So obviously when you're testing it, like, you don't know where
Yeah.
So we did a similar thing. We made like a big version of our location tracking stuff that just kind of puts you at one fixed, like one predetermined location.
Right.
And moves you at a predetermined.
Okay. So every time you run a test, it's always going to return coordinates that happen to be like in this building sort of thing, even if you're at home. But when you actually use the device and you are actually at home, it will return the coordinates for whatever your house is. You don't have to share that right now. Okay, good. Thank you. Thank you. And I think Team 2 is the same problem. I think Team 2 is a similar problem.
It's not based on your location. You actually feed the location.
Okay.
And so you can kind of determine.
Okay.
Given, because you can give whatever address you want.
So in your case, you're injecting the location itself as opposed to injecting what you're getting location data from.
Exactly.
Okay, okay. Okay, good, good. All right. I'll put this sample up on the course webpage. I'll put this up on the course webpage. I mean, this obviously isn't going to compile because it's just a bunch of random stuff, but the structure should hopefully be helpful for you to see kind of what the approach should look like. So I'm actually going to save this. Oh gosh. Random source in class example. And I'll just save it to my home directory like a monster. Okay. Good. So that's it for testing. That's actually it for testing because we've only got 10 minutes left in class and I've said like this is the last content class. So that's really it for testing. The last thing that I want to spend a little bit of time taking a look at is, how we're going to go about telling people about our work. So the last part of software development, and I know you're kind of in the heat of, we're still trying to finish that last part, but part of the last parts of doing software development is selling it. You've worked hard on this thing. You've worked hard on this thing. You want to tell people about it. You want to tell people about the hard work that you've done. You want people to buy your software. You want them to use your software. Our presentation for this course is going to be creating a website for your product. So creating a website for your product doesn't have to be super fancy. It's just a static website for your product, but I want you to convey certain information about your project and your product in this website. Here are some examples of websites that substantially cover the required parts of what I'm asking you to do for the presentation for this course. I'm going to give you a 30-second overview of what each of these are because I'm going to ask you to pick one and evaluate that website with a bunch of questions. NewPipe is an Android YouTube client. It's an open source YouTube client for Android that has everything that you'd expect in a YouTube client. It lacks advertisements, which is nice. It lacks ads, but sponsored by whatever still shows up because it's that talking head actually saying it. Strava is an activity tracking and social networking software where you can track things like bike rides and swimming and running and walking and hiking, and you post it and you share it with your friends and whatever. AntennaPod is an open source podcast management software, also for Android. Blockada is an open source firewall tool. It's a VPN-based firewall tool for Android. Its primary use case is it's a VPN, but it's actually an ad blocker. So you can load hosts lists into it, and it will, without having to root your phone, it can stop ads from showing up based on host names. And then Polytopia is a game for Android. It's all Android stuff. I'm sorry, iOS people. It's a game for Android. It's a game. It's a game. You can check it out if you want to see what it actually looks like. Here's what I want you to do. Pick one of those websites. It doesn't really matter which one, but these are the things that I'm looking for you to do with your own website. I'd like you to take the time to try and identify some of the things that we talked about earlier in the course, so the vision, the features that are part of this product, who it's targeted at, who are the end users of this thing supposed to be. I want you to look at the demos, Do they have screenshots for their app? Is it a carousel? Is it an actual video? Is it an animated GIF? What is it? What do they actually show? Are they trying to demonstrate specific features that they described in one, or are they just showing you random stuff in the app? And then finally, what makes this website appealing to you? What makes it look good? Again, I'm not going to evaluate you on how good your website looks. Please don't make it hot pink and brown. Please don't do that. But, you know, if it's just plain text, I don't really care. I don't really care. These websites, for the most part, have some kind of funding. So what makes it appealing to you? And then just broadly, would you use this app? There's about 5 minutes left in class. Please take about 5 minutes to pick one of these things, look at it, get a sense of what's going on in this website. Would you model your own website after this? Please go ahead. All right, so let me just quickly wrap up before you take off. At this point, you should be able to describe how to change legacy code. I'm not expecting you to actually change legacy code. That is not what I'm expecting. I'm expecting you to describe what you would do to change legacy code. You should be able to refactor and test non-deterministic code. If this exists in your code base, my expectation would be that you have tests for non-deterministic code now. And you should be able to evaluate a presentation of a software project as a way to inform your own presentation of a software project. That's it. Thank you. I will see you all next week. Bye, everybody.